I want to talk more about the net filter NAT table for source address translation. See, I have a IP table output here for the NAT table. So when you look at those chains and which chain reference which chain, which can be really confusing. Just look at those text output. And the reason why we needed to look at these guys masquerade with the mark with this flag for the source address translation. And so let's go back to the diagram. So this is the diagram for a packet generated locally on the Linux. Yeah, so this is output path. And the local process generate the packet route decision. So what we need to focus on is the NAT table. So if you look at the NAT table here, only the output chain in the NAT table and the post routing chain in the NAT table is referenced here. So I take out this diagram and just the NAT table chain diagram, and so I draw a new diagram here. I draw a new diagram based on the NAT table output rules. So those rules, it's hard to see which one reference which one. And so I draw a diagram here, then it would make it much clearer to explain. So again, a NAT table, it has an output chain and a post routing chain. So first it goes through the output chain. Then the output chain referenced the Kubernetes services chain. And the Kubernetes services chain referenced the Kubernetes mask chain. And in this chain, it has the rule to mark a packet with this flag. So yeah. So if we look at this mark all packet source from any to any with this flag, right? So that's what happened in the output chain. We have a path in the output chain to mark a packet with this flag. So that's all the job done in the output chain. So after the packet goes through output chain, here it will go through the ladder table come here, NAT table, the post routing chain. So in the post routing chain, it referenced the QB post routing chain. In the QB post routing chain, it referenced the masquerade target. So let's look at the QB post routing chain. So here's the QB post routing chain. It has two rules. So this masquerade rule is what we are interested, because it will do the source address translation for any packet with this mark flag. Yeah. So if we look at the original output here, as you can see, QB post routing chain, it will if any packet marked match this flag, go to this masquerade target. So what does masquerade target do? So in general, it is for address translation. And so let's go to our diagram here. So eventually this is the net filter target we are going, the packet going to hit, and the packet is marked with this flag, will go to this target. So what did this net filter target actually do? So we can go look at the source code here in the kernel. So this is the IP table masquerade .c file is the source code for implementing this masquerade target. So in the beginning of this C file, you will see module description. It says automatic address translation for source address, and this is a struct to register masquerade target. As you can see, the target name is masquerade, and the actual target function is the masquerade target TG, and it is registered in the post routing chain net filter hook. Yeah, so if you are familiar with the net filter hook in the kernel, so you will have a better understanding, but we don't need to go into detail with this hook. And so what we are interested in is this, what the masquerade target actually do. And so if we go down here, this is a masquerade target function. And from here, you will see it calls another NAT masquerade IPv4 function, which is for IPv4 packet. And so if we go look at this function, NAT masquerade IPv4, then we will notice here it has a line here to select a new source IP address. Here, it's a kernel function, and to select our source IP for any outgoing packet from the Linux, and get a new source IP, and the last line here is to do the actual magic to manipulate the source IP with this flag, NAT manipulate IP source IP. And yeah, so we don't need to go into detail of those is a kernel magic. So But that's the basic logic. And we come back here again. So my solution is to like um, we should mark mark the SIM packet with this flag, and then eventually come here post routing. It will do the source address translation for us. But right now, we in the Kubernetes services chain, we only have this, only reference to this guy, but with only this a source is from non 10.0.0.0, but our SIM packet, our three-way handshake SIM packet is coming from 10.0.0.1, which does not match this source IP range. So that's why the packet is not marked by this flag. So yeah, that's the solution I'm trying to resolve. Yeah, hope this makes you understand better.